This is grade 11 quadratics number 2. In this one, I'm going to do some examples, okay, how to factorize or how to find the roots of a quadratic equation. We're going to use the formula, and I'm just going to give you a little couple of hints of how to do it. I'm going to do it using completing the square, and then I'm going to go ahead and I'm going to look at the nature of the roots of a quadratic equation, okay? Let's just have a look here. We've got our quadratic equation. We've got 3 ways to factorize. Number 1, we've got, need to go back there. Number 1, we've got the good old-fashioned 2 brackets equals 0 to find the roots, haven't we? Well, we know that one, put it equal to 0, and we find these numbers in here, all right, like so, and we can factorize it, okay? For those of you who've got the calculators, congrats, that makes it easier for you. Please remember, okay, when you do that, just make sure that you actually got the correct answer, right? Because your calculator, for example, let's just do a very simple one. Let's say I got x minus 2, x plus 3, like that. That comes from x squared plus x, okay, minus 6, doesn't it? Okay, minus 2x plus 3x is plus x, and it's a minus. That, so if we put in the calculator, we'd put in a 1 there, plus 1 there, minus 6. The calculator would give us x1 equals 2 and x2 equals minus 3. Remember, that comes from the calculator said x minus 2 equals 0, x plus 3 equals 0. Then it solved and gave you, that went across and gave you your 2 and your x equal to minus 3. All right? Please, I know that increasing numbers are using the calculators, which is great, allows us to get through more work, but you've got to understand where this stuff comes from, because when you're solving this, very often what some students have done, they've said that and they've said, okay, therefore x plus 2 equals 0. No, not the case, okay? Just always remember where it comes from, what it represents in your answer. So now, okay, this question number, section 2, number 2 was by completing the square. Number 3 is by work using the formula, okay? Now, they are going to ask you, they're going to tell you by completing the square or the formula. Recommendations, don't do completing the square unless it's asked for, okay? It's long, it's complicated. The chances of an error are very high, especially when you've got horrible fractions, okay? The easiest one, first of all, if the brackets don't work, use the formula. Only go to the third one, completing the square, if you are asked to do so, all right? Let's do the following. They say solve for x in this case. 3x, here's an example. 3x over 2 minus a quarter equals 5 over 4x. Okay, well, we've got fractions here, okay? Yes, you can bring that to the side, add them all together, but remember, if it's only one term, you can multiply through by the LCD. Remember, the other way of doing it is bringing them all to the other side, okay? Here, what do we say? We say, nope, let's do it. We multiply by LCD. When you do this, please, can you see the LCD over here is equal to 4x. Then go 4x over 1 times 4x over 1 times 4x over 1, and then cross cancel, okay? Do not try and do it in your head. You will, chances are, forget one of the terms, all right? Then we go and we say you are 2, that leaves us with a 2x. That cancels, leaving with an x. That whole thing cancels and leaves us with a 1. Now we can go and we can write down that 2 times 3 is 6x squared minus x equals 5. I could have brought that across straight away. Let's bring it across now. Not a 4, it's a 6. 6x squared minus x minus 5 equals 0. Okay? Right, now we say, okay, part 1. we can factorize using the brackets, okay? So we say that's a 6x, and over here, that's going to be an x, that's going to be plus 5, that's minus 1. Therefore, we say 6x plus 5 equals 0, x minus 1 equals 0, and therefore x is going to be minus 5 over 6, or x is equal to plus 1. Okay, that's using the good old factorizing, right? Next, let's use the formula. Let's use the formula, shall we? What does the formula say? The formula says it's x is going to be minus b plus or minus the square root of b squared minus 4ac, like so, right? And it's all over 2a. Now my trick, my hint to you is to do this. You write your formula, your quadratic down. 6x squared minus x minus 5 equals 0. Then take out underneath it a equals, b equals, and c equals. Okay? Not that. Take them out. 6 minus 1 minus 5. Why? Because the coefficient is actually minus 1, isn't it? I've got it. Let me just just tidy this up a bit here. Minus x. The coefficient here is minus 1. All right? The constant is minus 5, and a is that. So if we had, let's say, minus 2x squared plus 3x minus 5, a would be minus 2, b would be plus 3, and c minus 5. So you take the sign with it, extract them out of the formula, of the equation, okay? And then we can now say, therefore, x is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. Now we're going to substitute in for a, b, and c, right? A, we're going to substitute in minus 6, like that, correct? Okay? A, b, Kevin, is b is going to be minus 1, right? Plus or minus b squared is minus 1 squared. Minus 4 times a is 6 times c is minus 5. All over 2 times a, which is 6. I can only ask you to please do this. Use brackets. Use brackets. Use brackets. When you substitute in, use brackets. It is beyond critical. The errors here are just amazing. All right? 90% of the errors are because people don't use brackets. Okay? And sadly, I am dead serious. All right? So now we say, right, minus times a minus is a plus 1. Plus minus. Let's work it out. Minus 1 squared is 1. Okay? Then this is going to be minus times a minus is a plus. 5 times 4 is 20 times 6 is 120. All over 12. Plus 1, plus or minus the square root of 121 over 12 is going to be equal to plus 1, plus or minus 11 over 12. Now I can go and I can write my two roots. Yep. Number 1, x1 is going to be plus 1, excuse me, plus 11 over 12, which is, just write it down here, is 12 over 12, which is equal to 1. Okay? Then the next one, the next one, x2 is going to be plus 1 minus 11. Guys, here's our two options, right? There's they are. There's the plus and the minus. That's number 1. This is number 2. Okay? That gives us x1 and x2 over 12 plus 1 minus 11 is minus 10 over 12. And that simplifies to minus, divide both by 2, 5 over 6. Okay? And it is the same answer as the previous one. Okay? Last one I'm going to do it by completing the square, because we're going to do all three is completing the, I'm so tempted, I'm always tempted to do a square, because in cubes I've always done like that, difference of two cubes or whatever the case might be, just for the heck of it, you know. You got to add a little bit of fun into maths now and again. Hey, right, let's now see what are we going to do with this. Complete the square. Step 1, write it down. Okay, we know it is 6x squared minus x minus 5 equals 0. Step 1, take out the coefficient of x squared. Remember, I'm not going to write them down again. Okay, I'm going to say take it out. That leaves me with a 6 there and a 1x squared there, minus 1 over 6 times x minus 5 over 6. I could also have written that over there as x over 6. It's the same thing, right? I've just written it as minus 1/6 just to focus my mind on the coefficient, right? Okay, let's continue. Now I said divide through by 6. Okay, leaving us with x squared minus 1/6 x minus 5 over 6 equals 0. Next, open up a gap. Let's do it in red. I've always done it in red. Let's continue to do it in red. Okay, before I get there, let's continue. There is my gap 1. Here is gap 2. So it's minus 5 over 6. And here is gap 2. Please don't skimp with paper here, guys. Okay, you need the space. These get long. Now what do I add in? I'm going to go red now. I add into here plus half of that. What is half of a 1/6? If you are worried, take your calculators and go 1 divided by 6, and I'm not being paternalistic or facetious, okay, is 1/6, and then divided by 2 equals, and it'll tell you a 12th. All right? Because my point here is, and square it. And on this side, then we subtract 1/12 squared, like so, right? I want you to get it right. That's the key here. And sometimes some of these fractions can drive us insane. If you're in doubt, you can use it, okay? Unless told not to, obviously, right? But when you're completing the square, my view is in order to make sure I'm 100% right, I can use it. So then I say, okay, multiply out, and I get x squared minus 1/6 x. I forgot my x, sorry. Okay, plus 1 over 144 minus 5 over 6 minus 1 over 144 is equal to 0. Okay, so far so good. What do I do now? Now I factorize this guy. And I know he always does this. An x, because it's the square root of that. The square root of that is going to be 1 over 12, and it's going to be a minus sign because I use that sign there. Square root of this is always an x. Over here, in fact, it's always going to be that x. Minus, you take the sign from here. Goes into there, correct? And it's the square root of that term. Minus 5 over 6 minus 1 over 144 equals 0. What do we do with this? We just carry on, all right? And then we say this is x minus 1 over 12 all squared. Take that to the other side. It becomes 5 over 6 plus 1 over 144. And I tell you what, let's add those together. Once again, use it, okay? It's actually quicker than trying to work it out by doing equivalent fractions and so on. Eventually, you end up with 121 over 144. All right? Perfect square. We'll get to that in a few minutes. What do I do next? I take the square root of both sides, right? Green. Square root of both sides, don't we? That leaves us with x minus 1/12 is equal to plus or minus 11/12. Therefore, x is going to be equal to, take it to the other side, 1 over 12 plus or minus 11 over 12. Now, therefore, I've got two roots. x1 is 1 over 12 plus 11 over 12. It doesn't matter which way around you do this, okay? And x2 is going to be 1 over 12 minus 11 over 12. And that's pretty easy. That's 12 at the bottom. It becomes 12 over 12, which is 1. This is 1 minus 11, which becomes 10 over 12, okay, minus, which becomes minus 5 over 6. All right, and we get the same again. Okay, so all three have given us the same answer. I've done it now, the three. Remember, if you're taking it out with the formula, and we do some a bit further on, if you're taking it out with the formula, extract your A, B, and C first, okay? Extract them underneath out of the way so that when you put them in, you put them in the safety brackets, right? The safety belts. Put them in brackets so that when you square it or times them, you're not forgetting the sign, because that's where it goes pear-shaped and wrong, and students get some very weird answers, okay? To what's actually very simple task, all right? And the third one I've done is completing the square. That's quite a rigorous load of examples on that one. Now, the next topic in this part is the nature of roots. All right? The nature of the roots of a quadratic. All right? They will ask you, comment on the nature of the roots, give you something and say, what do we do? What must this be for it to be real, imaginary, or whatever? Just let's think about what we're doing. First of all, I want to start with the formula we've just used. X is equal to minus b plus or minus the square root of b squared minus 4ac over 2a. That's the formula that we've just derived. Okay. Now, there's a very, very interesting and a very useful piece, which is that guy. Because without going through all of the motions here, there's a lot of work that we can do just using this b squared minus 4ac. b squared minus 4ac. It's so important that it's got its own name. Okay? What do we call it? We call it the discriminant. Okay, the discriminant, and it's called delta, is equal to b squared minus 4ac. 4 times a times c, right? The discriminant delta is that. Why is it so important? Why? All right. Well, hold on. What if delta was less than 0? In other words, it was a negative number. What would you say then? Well, the next step is, we say in the formula, the next step is we're going to take the square root of b squared minus 4ac. That's the same thing as taking the square root of delta. But delta is negative, which means we're taking the square root of a negative number. What does that mean? Well, you can't. Okay? It actually means that this has got no real roots. All right? It's not possible to do that. If we did, let us say, just for argument's sake, all right, let us say we had this, shall we? All right. Let's say we got an answer. Let's say we worked out delta was equal to -9. Therefore, the next step is we're going to take the square root of delta, which is the square root of -9. Now, we can simplify that because that is the square root of -1 multiplied by 9, which is equal to, I can find that square root. It's the square root of 9 is, so I can take it out from under the third, 3 times -1, which gives me, and here, do you remember that you and I'll be doing it in a few minutes. I'm going to do a little flow chart with you. Okay? Do you remember that early on we started off with numbers and we split them into real and we split this into non-real? Right? Well, this here, this square root of -1, all right, is actually over here, isn't it? We call it I, right? It forms basically non-real, can also be called imaginary numbers. Also, they fall into the complex numbers, right? So if you do on your calculator, if you use the function which says, please would you help me with this and solve it for me, and it gives you 1 plus 3i, what it actually means, that I there, this guy, is it actually means this is 1 plus 3 times the square root of -1, because I is the square root of -1. And what that actually means is it's actually 1 plus root -1 times 9, which is 1 plus root -9. That is how your calculator comes down to that I situation. It means that there's a complex number, an imaginary number, a non-real number involved. Now, I'm going to do this flowchart, okay? I'm probably going to put it in for a download, but let's just go through it, shall we? We said we got numbers, all right? Okay, let's just take this nice and clean out of the way. We're starting off here with numbers. And we're going to split our numbers into non-real and real. All right? Now, what we say here is we say these are our non-real, imaginary or complex, all right? Just be careful of how it's asked. Depending on who's setting papers or what's happening, it can be asked the complex part or the imaginary part or the non-real part. Let's just see. This means over here that delta must be less than 0. Right? If we've got a delta less than 0, we will have non-real roots. Right? For real roots, okay, we've got two options. Well, basically for real roots, let's just put this in first. For real roots, okay, therefore, what is the opposite to that? Okay, the opposite to that is delta must be greater than or equal to 0. This is less than 0. This must be greater than or equal to, right? Because after all, either delta is going to be from 0 up towards infinity, or it's going to be minus down to minus. And if it's here, it's there. And if it's a positive number, it must be there. Okay. Now, the next thing is we can split this again. We can say delta equals 0. All right? We then get equal roots. All right? Oops, let me just leave it there. Can you see I'm just splitting apart these signs? Delta greater than 0, we get unequal roots. All right? And the last bit, okay, is I'm going to say the unequal roots. I'm going to split those again, and I'm going to say delta is a perfect square. One, 4, 9, etc. Then the roots are rational. And delta not equal to a perfect square. Delta is not equal to a perfect square. The roots then are irrational. Right? So let's just go through this process. We started off at the top with numbers. We split numbers into non-real and real. Non-real section must have delta less than 0. So on the number line over there, on my number line, okay, if anything is here, this is non-real. These are real roots, right? The roots, I'm talking about the roots, not numbers, non-real roots, okay? So if my discriminant delta comes to be a negative number, I don't have real roots. Why? Because I'm going to end up with the square root of a minus, which I can't have. Unless you do complex numbers, right? Which they do in AP. Okay. Then the other side of it is the only way other thing delta can be is greater than or equal to 0. Which means then I've got real roots. The next is to split the greater than or equal to 0 into greater than 0 and equal to 0. If it's equal 0, I have got equal roots. Real equal roots. So over here, these are going to be real equal roots, aren't they? And over here, they're going to be real unequal roots. And the last bit is they're going to be real. This one is going to be real. Okay, there. Unequal and rational. All right, that's the final sort of breakdown of it. This one over here is going to be real, unequal, and irrational. All right. Now, what I'm going to do is I'm going to use all these. Where we're going to do a couple of examples in the next session where we're starting to prove this. Then we're going to move on to quadratic inequalities. Okay. So the next bit is we're going to do examples using this delta, the discriminant. Okay. You can see quadratics. We're already up to the second session. Then we're going to go into inequalities and graphs of quadratics, etc., etc. So they're quite a big chunk of the work, right? I'll see you in the next session. Cheers. Hope you enjoyed that. Bye.